when an object is placed in a liquid, there are two forces that act on it. The first one is related to its mass, which is the weight, and the second force is the weight is a downward force, and the second one is the buoyant force, which is an upward force. Now, the buoyant force is related to the liquid that is displaced by the object. So the volume of the object and the density of the liquid determines this, as we will see in the examples. So if we have a look here, here is a steel ball of mass 1 kilogram, and then I have a steel ship of mass 2 kilograms. So the steel ship is actually of greater mass than the ball. However, the ball will sink and the steel ship will float. Why? Well, look at the amount of water that the steel ball displaces. It's a very small amount of water. It's a small volume, although it's quite a great mass. Therefore, in this case, the weight of the steel ball will be greater than the upward force of buoyancy, because only a small amount has been displaced. Therefore, it will sink. But if we look at the ship, you will see that a very large amount of water has been displaced. Although it's got a great mass, a greater amount of water has been displaced, and therefore the downward force of weight is smaller than the upward force of buoyancy, and therefore the ship will float. So basically, an object will float on another object if it is less dense than that object or liquid. So let's have a look at these questions. So you are given four objects, well, 2 liquids and 2 solids. Liquid A, density of 0.8. Liquid B, density of 1.2, solid C, density of 0.6, and solid D, density of 2.8. So first of all, the first 2 are fairly easy. With reasons, will C float on both A and B? Now, C has got a density of 0.6, A has got a greater density, 0.8, and B has got a greater density as well. So yes, the answer is true. C, because it's got the smallest density, will float on both A and B. And let's look at number B. Will A float on B if they don't mix? Yes, it's like oil and water. So if I had to draw a little sketch of a little cylinder with A and B, this is what the 2 liquids would look like. So this would be A with a density of 0.8, and this would be B with a density of 1.2. So that is true. And then C, D will float on B but sink in A. So if D has got a density of 2.8, will it float on B with a density of 1.2? No, it is more dense than B. So it will not sink, it will not float on B, but it will sink in A. So this is partially correct. So D will float on B, false, but it will sink in A. That is true. And then number D, C will float deeper in A than in B. If we have a look at these 2 diagrams, I've drawn them 2 beakers here, A and B. Now, A has only got a density of 0.8. So actually, A is less dense than B, meaning it has less mass in the same volume. B is more dense, in other words, it has more mass in the same volume. So if you look at C, which has got a density of 0.6, and A, which has a density of 0.8, they're very similar. So because there's not that much mass of water, there's not going to be a very big buoyant force pushing upwards. So C will float fairly low in the water because they've got such similar densities. So there you can see only a little amount of C is sticking out because C has got a density of 0,6 and A has got a density of 0,8, not C, sorry. Okay, so the water's got a density of 0,8. So you can see very similar, therefore it just floats very, very, just a little bit above the water. Now, if you have a look in B, the density of liquid B is 1.2, right? So it's dense, greater mass. So it's got a greater upwards buoyant force because there's more mass. And therefore it pushes C more upwards in the liquid. So actually you can see that there's a greater portion of C that is above the water compared to in this diagram over here. So C is 0,6 and this water is 1,2, and because there's such a great difference, this is pushing up on C and it actually floats much shallower than in A. And then the last one, if C is placed into a mixture of A and B and they do not mix, it will come to rest on the dividing line. That is false. Here we have a density of 1.2. This is 0,8 and 1.2. So it's like oil and water. They will rest on top of one another. But because C has got such a small density, it's going to sit right at the top here and definitely not on this dividing line.